Hi, welcome back to OCR MEI past paper walkthrough. Today we're doing the section B of the 2017 paper C4. So let's go and have a look at question 7. So question 7 involves a differential equation dy by dx equals to 9x over 4 in brackets y equals 3. And the curve is shown as below. Part 1, show by integration that the curve equation is 9x squared minus 4y squared minus 24y equals to 0. So in order to find this equation, we must integrate. So let's do the separation of variable. Y plus 3 dy is equal to 9 on 4x dx. Add in the integrals and start doing it. So you can just quite obviously differentiate most of these. The constant can leave it onto the right, because they can add together and you basically eliminate one variable there. So you've got this kind of formation, and according to the curve, and it goes through the origin. So when y is 0, x is 0. So this side will be 0 and this side will be 0 plus c, and we can deduce that c equals to 0, which will be very useful so that we don't need to care about it. Then if we go back to this equation, multiply everything by 8, then we should be able to get on the left hand side 4y squared plus 8 times 3, 24y equals to just x squared, well, 9 lots of x squared. C is 0, so we didn't put it down, and by rearranging this towards the right hand side, we can get the equation that was desired here. So after this, we can find the volume of revolution and give the answer as a multiple of pi. The way you do this, because we're rotating along y-axis, we actually want to differentiate, we want to integrate x squared by dy. So the volume V will be equals to pi times the integral of x squared dy from the 2y limits, which is given as 2, and it ends at 0 because the domain never, the range never reaches negative y. So we have 2 and 0 on this, and by rearranging this equation again to get x squared, we can tell actually it's better to rearrange this equation. So divide by 9, you get x squared equals to 4 over 9 y squared plus 24 over 9 y. And if we factorize out most of the values, we can have 4 on 9 integral from 2 to 0 of just y squared at 6y dy. And that again is a very straightforward integral. Just make sure you keep the pi in at all times. So this will give me y cubed on 3 plus 3y squared, and limits. That in turn, if you substitute everything into the bracket, you should be able to get a value of 176 on 27 lots of pi. That's what I got. And yeah, that's 2 parts done. That's 9 marks. And now part 3, use the substitution x equals to 2 tan theta and y equals to 3 sec theta minus 1 to verify that the first equation holds true, and we showed that the gradient function dy by dx can be expressed as a function of sine theta. So let's do part A first. Let's see. So if we have 9 lots of x squared, which is 2 tan theta, take away 4 lots of 3 times sec theta, take 1, all squared, then take 24 lots of 3 sec theta, take 1, and we evaluate this thing. We should be able to get 9 times 4, 36 times squared theta. Take, for this square I suggest take it slowly and actually like break it down. This is a 9 sec squared theta, take 2 secs theta, add 1, take 72 sec theta plus 72, and that goes to 36 sec squared theta plus 72 sec theta, take 36, take 72 sec theta plus 72, and you start to see a pattern here that is quite nice. 72 sec theta will cancel with the minus 72 sec theta, and you're left with a tan squared minus sec squared relation, which conveniently gives me for every tan squared take sec squared, you'll get minus 1. And so in this there are 36 lots, which means that I get minus 36. Remember, we have another minus 36, that's minus 72, and we have a plus 72 in the end, which gives me 0, which satisfies the first condition. For part B, we need to express that fraction as a trig function, which is doable. 9 lots of 2 tan theta divide by 4 lots of y, which is 3 sec theta, take 3. I just simply broke the bracket. Add 3 from the equation. Then we can see the minus 3 and plus 3 can cancel. Then we're left with this mess. 9 cancel with 3 to get 3. 2 cancel with 4 to get 2, which leaves me with 3 halves of tan theta over sec theta. Sec theta is 1 over cosine theta, so you multiply by cosine theta if you divide secs. And tan is simply sine over cos, and the cos theta can cancel out to give me 3/2 of sine theta. And therefore we can conclude that the value of k is just 3/2, which gives us another 9 marks. For question 8, it's actually quite tricky, and it can trip a lot of really good students up by just overthinking, but it's actually quite obvious what you should do. So you have parametric equations of x and y in terms of theta, and you have the take note that the theta is in radian form, so change your calculator setting right away. So part 1, find the value of theta corresponding to point B, hence find the coordinates of point B. So for point on this curve, B, according to the description, is a maximum x value, and according to this equation, x is cos 2 theta, and so the max x should be just 1, because trigonometry functions never exceed plus or minus 1, and B is clearly on the positive quadrant. So I've got 1 equals to cos 2 theta, and if we find theta, which conveniently will give you theta equals 0 after you've rearranged this, you should be able to find out that subbing into y equals to cos 0 gives me 1, plus 2 lots of sine 0 gives me 0, which gives me y equals 1. And therefore point B lies on coordinate 1, 1. So that's first part done. 2. Express cos theta plus 2 sine theta in form r cos theta minus alpha. So the way that you should do this is to kind of reverse engineering, start from this form and work backwards. So ignore the r for now and just try to break open the compound angle, which should give you cos theta cos alpha. Actually add sine theta sine alpha, and by expanding this we can find that r cos alpha is the coefficient of cos theta, which is also 1. So I've got this relation. For the sine theta version, we have r sine alpha equals to, according to the equations, 2. So I've got that. What about r? The value of r has to be the quadrature sum of these two coefficients, which is the 1 squared plus 2 squared equals to r squared. It's just like Pythagoras, which gives you r equals to root 5. So from then you can just rearrange for cos alpha equals to 1 on root 5. There will be a few different values, and for sine alpha we've got 2 on root 5, and using these two together, the only value that works is supposed to be in the order of 60 something degrees, which is also 1.107 radians. 1.107 radians. and so alpha is 1.107, which finishes part 2 of this question. Steaming onwards, we have part 3, find the coordinates of point A and C using that information. So given the fact that, let's start with point C. C is on the maximum y value, which means that the entire y trig function should be at max 1. And so 1 is equal to the trig proportion, or because it's r cos theta minus alpha, and r really doesn't matter, it's just a scale factor anyway. So the maximum value will be 1 equals to cos theta minus alpha, and we know alpha is 1.107 radians. By breaking this open, we can tell that let's see, our cos of 1 is 0, so theta take 1.107 is 0, and we know that theta has to be 1.107 radians. With that in mind, we can find the value of x and y. Essentially plug it into the calculator. You should get, well, for the x value, you should get minus 3/5, which is also minus 0.6. And the y value, because it is in this form, we know that it's a maximum value. So this function cos theta minus alpha is 1, and therefore we get r as our y value. And we know that the magnitude of r is just root 5. And so we've got point C. So what about A? To find A, we need to know that y is 0 during this time, or theta. So let's say y is 0 is also the r cos of theta take alpha, and so cos theta take alpha must be 0, and the thing that makes cos 0 is pi on 2, which is also theta take 1.107 radians. And so theta should be that pi on 2 at 1.107, which gives you 2.678 radians. Plugging that into the cos 2 theta equation gives you a value of x roughly equals to 0.6, and we know that the y value is 0, so we know the point A is 0.60. So that is part 3 done. So finally, we've got part 4. The angle beta is the angle between the two tangents at A, and we need to find dy by dx in terms of theta, then assume the scale of x and y are equal. Basically means that they're kind of linear on the graph, and so you can just do simple geometry. Find beta, the angle, and give it in radians to 2 dp. So given that the curve is symmetrical about the x-axis, all we need to care about is either the lower half angle or the top half angle. Let's see what happens. So let's start with dy by dx. To find that, we want to divide dy by d theta. We want to multiply dy by d theta by d theta by dx. So let's find dx by d theta first, and we can take reciprocal of that and it would work. So by chain rule, we know it is minus 2 sine 2 theta. Dy by d theta, we know it's minus sine theta plus 2 cos theta. And with that, we can find dy by dx equals to minus sine theta plus 2 cos theta divided by minus 2 sine of 2 theta. So I've got the dy by dx term. It didn't say simplify. Don't really care about simplifying, really doesn't really matter at this point. So what we want to do is to now find the actual gradient, and according to the previous part, we have found the theta of A as 2.678. Plug that into the equation, we get dy by dx equals to, let's see what I get, minus 1.3976. From this we know that it's the negative comes from the bottom, the diagonal going downwards, and so we can construct a triangle. And to say, let's say this is half beta, because of this, and this is the x-axis, this is down, going down the y-axis. Since dy by dx is minus that, which means that in a change of x, let's say arbitrary value of 1, we go down negative y, this is the negative direction, 1.3976, so this is 1.3976, and there we have a trig function of tan half beta equals to 1.3976 divided by 1. From that we can deduce that beta has to be well, actually half beta has to be 0.9498, and therefore beta is 1.90. So there we go, we have finished the C4 paper. Overall, I feel like this paper is, firstly, the section A bits are quite straightforward, they shouldn't really pose a problem, and section B, especially question 8, could be a bit more tricky. However, I think question 7 is totally doable as long as you have clear algebra, and if you don't do minus lips of like plus or minus signs, then you should be alright. Anyway, hope you enjoyed and hope you've learned something. Feel free to leave any questions in the comments below, and I will see you on my next one.